Hey class, I hope you're doing well. Alec here, very frustrated. This is the sixth time that I've had to go over this lecture. Um, this is, I'm not going to redraw it. It's going to have a whole bunch of doodles on it. I'm going to talk quick. Last time I looked at my clock and it was 16 minutes and 4 seconds. I have 15 minutes to get this done. So, without talking any further about that, let's go on and I will talk quickly. You can always pause this and look at stuff on here. We're talking about the cost of production. A firm's costs are determined by its production function and the prices it must pay for the inputs. Remember this, C is a function of Q. We're starting with dollars. We know that some inputs are fixed and some inputs are variable. Namely, labor is our variable input. Now, obviously, there are other variable inputs such as material costs, which we call intermediate goods and services, as well as potentially utilities. Okay, but let's focus on labor. This equation, you must know this equation. Your total costs are equal to the sum of your total fixed costs plus total variable costs. Fixed costs are associated with your fixed factors, land and capital. Variable costs are associated with our variable input, that's labor. Our total fixed cost curve looks like this. It's simply a flat line. Okay? In this example, imagine this. Imagine that the only fixed cost that a firm have is the monthly rent, and that's $1,200. Just start at $1,200 and run your function all the way across. Horizontal means it's constant. So if this firm doesn't produce anything, it still has $1,200 in fixed costs. If it produces 1,000 units, it still has $1,200 in fixed costs. So fixed costs are independent of the rate of output. Over to the right in the purple, we have our total variable cost curve. Why does it look this way? Because if you recall, our short run production function looked like this. The way I derive this is that I say, okay, remember, our production output depends on the number of workers that you hire. Suppose that the wage rate of these workers is $80 per worker per day. If I hire one worker, I have $80 in variable costs. If I hire two workers, I have 160. If I hire three workers, I have 240. You can kind of see now I have this secondary horizontal axis where I have variable costs, but I want variable costs to be up on the vertical, and I want Q to be down here on the horizontal. So in essence, you just flip your function and or transpose your function, and that's why the variable cost curve looks like this, because the short run production function looks like this. Now you know that total costs are the sum of fixed costs and variable costs. So just bring these two graphs and add them together. Your sorry about that. Your total cost curve is nothing more than your variable cost curve shifted up by an amount equal to your fixed costs. Here is specialization, here's diminishing returns, and here's where your costs go up significantly. Okay? Now, the information that we get in the marketplace, we know this total cost, top box here, is equal to total fixed cost plus total variable cost. These are in dollars. The information, though, that we get from the marketplace is in dollars per unit. Price is equal to dollars per unit. So we have to convert this into an average total cost curve, and you do that by simply dividing by Q. So I divide the entire equation by Q. I can break out the parts, and then I come to this equation in this box that you must know. Your average total costs are equal to your average fixed cost plus average variable cost. Okay, in the blue here, think about this. Your total fixed costs are constant. Therefore, as you add more units of output, your average must fall. This is in the denominator on the right hand side of the equation. So go back to the example. Our total fixed costs are $1,200. If I produce one unit, my average fixed costs are equal to $1,200. If I produce two units, 1,200 divided by 2 gives you 600 in average fixed costs. 3 units divide, or excuse me, $1,200 divided by 3 units is $400 in average fixed cost. So the moral of the story is your average fixed cost curve will slope down and to the right. It'll run closer and closer to the horizontal axis, but it will never touch. Your total variable cost curve, we remember your total variable cost is kind of flat at first where specialization of labor occurs. Therefore, your average must be falling initially. Okay? The average variable costs, your total variable cost curve kicks up and rises significantly. Therefore, your average variable cost curve must eventually rise. Your average total cost is nothing more than the sum of your average fixed costs and average variable costs. Both fall at first, so the average must fall. And then average fixed cost gets really, really small, and average variable cost gets really, really big. It's like a tug of war between the two curves. Therefore, your average total cost curve must kick up and to the right. Let's go over this again real quick. Here's an average fixed cost curve. You're right. Here's an average variable cost curve. Got it. Okay, both are falling at first, and then average variable cost rises, average fixed cost gets really small. So your average total cost curve looks like that. It is distinctly U-shaped. Everybody okay with that? Okay, let's go on to this one. Now this is going to look really confusing, but again, I'm not going to write it out because I've done it 6 times. What we're talking about here, we talked about this before, the marginal product of labor is the change in output from hiring one more worker. Delta Q over delta L, where delta L is equal to 1. Stop and think about this. Over here, the slope of your production function is equal to the rise over the run, right? That's equal to delta Q over delta L. Notice it's equal to the marginal product of labor. I'm going to draw your marginal product of labor curve here in dark black. It looks like that. Okay, so where the marginal product of labor is rising, where we have specialization of labor, that's very early on. We hit the point of diminishing returns, and then the marginal product is still positive, but it declines. You can see here this is a flattening of your production function. Why is this important? Because it'll help us understand what the marginal cost curve looks like and why. The marginal cost curve is equal to the change in total cost from producing one more unit. You can see that up here. It's equal to the change in here's the formula for it in that second circle, now a box. But we know some costs are fixed, therefore we can essentially ignore them. Your marginal cost is equal to the change in total variable costs over a delta Q, where delta Q is equal to 1. How does your variable cost curve or your variable cost change? It changes, it's based on the wage rate and the number of workers that you hire. So I've drawn this out here in the numerator on the right hand side. Your variable costs, or the change in your total variable cost, is equal to the wage rate times the change in labor. Okay, I can pull this apart, pull the W over here and have this ratio over here. The marginal cost is equal to the wage rate times delta L over delta Q. We can rewrite this and say it's equal to the wage rate times 1 over delta Q over delta L, which is equal to the marginal product of labor. So here's an equation here, and again, it's nothing more. You don't have to understand this to take the test, but the marginal cost is equal to the wage rate over the marginal product of labor. What does this mean? Let me get the marginal cost curve in here and do it in dark black. It looks like that. It says this: as your marginal product is rising, which we see up here and here, specialization of labor, your marginal costs will be falling. As the marginal product of labor is falling, which you see the flattening of your production function and the downward slope of your marginal product function, your marginal costs will be increasing. So the marginal cost curve is nothing more than the marginal product curve flipped over. It's upside down. This has it's this shape here. This is now a Nike swoosh or a fishing hook. And notice what happens here, and this is kind of important. We can identify the point of diminishing returns. It's the peak of the marginal product curve, and it's the minimum of the marginal cost curve. We can identify specialization of labor. Looks like that area, it's the increase in the marginal product function and a decrease in the marginal cost curve. And then we can identify all points beyond that, the points of diminishing return. Okay, let's go one more, and I think we're going to be doing it. Come on. Here is now the cost model of the firm. I will put these in bold again. The marginal cost curve looks like this. It will always look like that. The marginal or the average total cost curve looks like this. Obviously, it's going to be above the average variable cost curve, and that looks like that. Okay. Now, what I've done here is that we have dollars per unit and we have quantity. I've designated a level of output. I'm changing to orange. Sorry for the confusion, but I'm trying to walk you through this without having to redraw the curves. I've designated a level of output, 100 units of output. Just run that output level up and find out where it intersects the two curves. Hang a hard left, and it hits your average variable cost curve first and your average total cost curve second. We know from this equation right here that average total cost is equal to the sum of fixed costs and variable costs. Average total cost minus average variable cost is equal to your average fixed cost. So this distance right here, the difference between ATC and AVC is equal to your average fixed costs, or AFC. Now, just to give you some numbers, imagine this, is that I'm producing 100 units of output. My average variable costs are $10 per unit. My average total costs are $15 per unit. Therefore, my average fixed costs are equal to $5 per unit. Does the math work out? Yes, it does. Here's the $5 in fixed cost on average and the $10 in average variable costs. The math does work out. So a little hint or word of advice, anytime you're looking for averages or marginals, you find them on the vertical axis. Okay? Anytime you're looking for totals, you get totals by boxes. So now notice what happens here. I take my average variable cost is $10. I multiply it times Q. I will shade this in again. It's going to go from blue to orange. Here's the equation. $10 times 100 units equals $1,000 in total variable cost. That is what we see right there. Okay, let me change colors here. Let's go to funky pink. Now, if I take average fixed cost of $5 and I multiply it by 100 units, I get $5 times 100 equals $500 in fixed costs, and that is that box. Does the math work out? It does. I've got now $1,000 in average in total variable costs plus $500 in total fixed costs. I come up with the $1,500 in total costs. Everybody okay with that? Good. Talk to you later. Bye.